What if I told you some of the most advanced technology we use today isn't as modern as we think? That the roots of our greatest innovations stretch back thousands of years, buried in the dust of civilizations long forgotten. From precision engineering that defies explanation to medical practices that still leave scientists scratching their heads, the ancient world was far more sophisticated than we often give it credit for. Picture this, a 2,000-year-old device small enough to fit in your hand, capable of predicting celestial events with astonishing accuracy, or a surgical procedure performed with tools so precise they rival modern instruments. These aren't myths, they're real, tangible mysteries left behind by cultures that vanished into the shadows of history. Today, we're uncovering 35 hidden innovations from lost civilizations, discoveries so advanced, so baffling, that they challenge everything we thought we knew about the past. Think of it as a treasure hunt through time, where each clue reveals a piece of a puzzle we're still trying to solve. How did the builders of the Great Pyramid align it with true north using nothing but the stars? What secrets lie hidden in the intricate gears of the Antikythera Mechanism, a device so complex it shouldn't exist for another 1,000 years? These aren't just historical footnotes, they're proof that the ancient world was a hotbed of ingenuity, creativity, and knowledge that sometimes surpasses our own. But here's the most thrilling part. Every one of these innovations has a story to tell, a lesson to teach us about human potential. They whisper of civilizations that reached heights we're only now beginning to understand, cultures that solved problems without the tools we take for granted. And as we peel back the layers of time, you'll start to see the past in a whole new light, not as a series of primitive steps, but as a dazzling tapestry of brilliance waiting to be rediscovered. So, if you're ready to journey into the unknown, to explore the mysteries that have puzzled historians for centuries, then let's dive in, because the past isn't just history, it's a revelation. Hidden in the depths of the Mediterranean Sea for more than 2,000 years, a corroded lump of bronze and wood would rewrite our understanding of ancient technology. When sponge divers stumbled upon it near the island of Antikythera in 1901, they had no idea they'd just pulled up the world's oldest mechanical computer. This wasn't some simple clock or decorative artifact. It was a device so advanced, so precise, that nothing like it would appear again until the 14th century. The Antikythera Mechanism, as it came to be known, was a masterpiece of engineering, a labyrinth of interlocking gears designed to predict celestial events with jaw-dropping accuracy. At first glance, the fragment seemed unremarkable, just another relic from a sunken Roman ship. But when archaeologists noticed intricate gear teeth embedded in the corrosion, the real mystery began. X-rays and modern imaging revealed a complex system of at least 30 bronze gears, some with teeth cut at angles so precise they could calculate the movements of the sun, moon, and planets. Imagine a handheld planetarium capable of tracking lunar eclipses or forecasting the dates of the Olympic Games years in advance. This wasn't just ahead of its time, it was light years beyond what historians believed possible for the ancient Greeks. The brilliance of the mechanism lies in its miniaturization. Each gear served a purpose, from modeling the irregular orbit of the moon to accounting for leap years. One dial even predicted solar and lunar eclipses by incorporating a cycle discovered by the Babylonians centuries earlier. But here's what really stumps researchers: the craftsmanship suggests this wasn't a one-off experiment. The level of precision implies a tradition of gear making, a school of thought lost to history. Who were the geniuses behind this technology, and why did it vanish for over 1,000 years? Modern attempts to recreate the Antikythera mechanism have only deepened the awe. Engineers using 21st century tools struggled to replicate its delicate gear ratios, marveling at how artisans with hand files and rudimentary drills achieved such perfection. Some speculate it might be linked to the legendary workshop of Archimedes, while others believe it hints at a broader, forgotten tradition of mechanical science. One thing's certain: this wasn't just a tool. It was a testament to human ingenuity, a whisper from the past proving that innovation doesn't always move in a straight line. Sometimes the brightest sparks flicker out, waiting centuries to be relit. While the Antikythera Mechanism reveals the ancient world's mastery of precision mechanics, another innovation from the past has literally stood the test of time: Roman concrete. Walk through the ruins of the Pantheon or the Colosseum, and you'll notice something extraordinary. These structures have weathered earthquakes, wars, and 2,000 years of erosion, yet their concrete remains intact. Meanwhile, modern bridges and buildings often crumble after just a few decades. What did the Romans know that we've somehow forgotten? The secret lies in a recipe lost for centuries. Unlike today's concrete, which relies heavily on Portland cement, Roman engineers mixed theirs with volcanic ash from the Pozzuoli region. This ash, rich in aluminosilicate minerals, reacted with seawater to form a crystalline structure that actually grows stronger over time. Modern scientists studying samples under electron microscopes discovered tiny mineral fibers weaving through the material like microscopic reinforcement bars. These fibers prevent cracks from spreading, giving Roman concrete an almost self-healing quality. But here's the twist: modern experiments show that seawater, the very thing we try to keep away from concrete today, was key to its durability. When seawater seeped into Roman harbor structures, it triggered a slow chemical reaction that filled pores with new minerals, strengthening the material rather than corroding it. Researchers have spent years trying to replicate this process, blending volcanic ash with modern cement, but the exact alchemy still eludes us. Some speculate the Romans might have added animal fat or even blood to their mixture, ingredients that would have been trade secrets guarded like national treasures. The implications for today are staggering. If we could unlock this ancient formula, we could build seawalls that fortify themselves against rising ocean levels, or highways that require less maintenance over decades. MIT engineers recently discovered that adding volcanic ash to modern concrete does improve its longevity, but even their best attempts only capture a fraction of the Roman material's resilience. Perhaps the real lesson isn't just in the recipe, but in the Roman mindset they built not for years, but for millennia, prioritizing endurance over speed and cost. What makes this innovation even more remarkable is how widespread it was. From the aqueducts of Segovia to the breakwaters of Caesarea, Roman concrete unified an empire's infrastructure. Yet after Rome fell, the knowledge vanished like smoke. For centuries, medieval builders reverted to weaker mortars, unable to match what their ancestors had achieved. It makes you wonder what other revolutionary techniques have slipped through the cracks of history, waiting to be rediscovered under layers of dust and time. Buried beneath the sands of Mesopotamia lies a mystery that could rewrite the history of electricity, a collection of unassuming clay jars that just might be the world's oldest batteries. Discovered in 1936 near Baghdad, these peculiar artifacts date back to the Parthian Empire around 2,000 years ago. Each one consists of a terracotta pot, a copper cylinder, and an iron rod sealed with an asphalt plug. At first glance, they look like ancient storage containers, but when archaeologists noticed traces of acidic residue inside, a shocking possibility emerged. These could have been primitive electrochemical cells. Reconstructions by researchers in the 1940s confirmed the jars could indeed produce a small electric current when filled with vinegar or lemon juice, natural acids the Parthians had access to. The iron rod and copper cylinder, separated by the acidic solution, created a basic galvanic reaction, generating around 1 volt of electricity. That's not enough to power a light bulb, but it's ample for electroplating gold onto silver or triggering mild medicinal effects. Some experiments even showed multiple jars linked together could produce a stronger charge, suggesting a deliberate understanding of electrical principles. But here's where the debate ignites. Without written records or clear archaeological context, scholars are divided on their true purpose. Some argue they were used for electroplating jewelry, pointing to gilded artifacts from the same period with thin, even coatings that chemical baths alone couldn't achieve. Others propose they had ritual or medical applications. Ancient texts describe using electric fish to numb pain, and these jars could have been a controlled way to replicate that sensation. Skeptics, however, counter that the jars might have simply held sacred scrolls, with the metal components serving as protective casings. What makes the Baghdad Battery so tantalizing is the implication of lost knowledge. If these were indeed batteries, it means the Parthians, or perhaps an even older civilization they learned from, were tinkering with electricity centuries before Galvani's famous frog experiments in the 1700s. Yet, unlike the Antikythera Mechanism or Roman concrete, there's no clear lineage, no trail of improvements leading to modern batteries. It's as if the idea flickered into existence and then vanished, leaving no trace in the historical record. Modern attempts to replicate the jars have only deepened the intrigue. Engineers note that the asphalt plug, once dismissed as a simple sealant, plays a crucial role. It prevents the electrolyte from evaporating while keeping the metal separated, a design nuance that hints at intentional engineering. Even more compelling are ancient Assyrian reliefs showing what appear to be priests holding vessels with protruding rods, standing beside what might be early capacitors. Could these be depictions of electrical rituals or just imaginative interpretations? The truth may never be fully uncovered, but the Baghdad Battery stands as a testament to human curiosity. Whether it was a tool, a toy, or something entirely unknown, it challenges our assumptions about technological progress. After all, innovation isn't always linear. Sometimes it's a spark in the dark, waiting centuries for someone to notice its glow. Scattered across the arid plains of southern Peru, a series of colossal etchings stretch for miles, spirals, geometric shapes, and towering animal figures so vast they can only be fully appreciated from the sky. The Nazca lines, created between 500 BC and 500 CE, are one of archaeology's most jaw-dropping enigmas. How did a culture without flight, without even the wheel, design and execute these intricate geoglyphs with near-perfect symmetry? And why would they pour such effort into art they could never see in its entirety? The precision of the Nazca lines defies simple explanation. Some stretch over 1,200 feet long, their edges unnervingly straight despite curving across uneven terrain. Researchers have found small wooden stakes at key points, suggesting the Nazca people used rudimentary surveying techniques, and perhaps ropes anchored between posts to maintain alignment. But even with these tools, the scale is staggering. A hummingbird's beak points perfectly toward the setting sun during the solstice, while a spider's elongated leg aligns with celestial patterns. These aren't random doodles, they're a celestial map, a ritual calendar, or something even more profound. Recent drone surveys have uncovered over 50 new geoglyphs hidden for centuries, including humanoid figures and surreal creatures with multiple heads. What's striking is how these newly discovered lines differ from the classic ones, smaller but even more intricate, suggesting they served a different purpose. Some archaeologists propose they marked pilgrimage routes, while others believe they were offerings to deities believed to dwell in the sky or underground water sources. The Nazca culture thrived in one of Earth's driest deserts, and the lines might have been a desperate plea to unseen forces controlling the scarce rains. But here's the twist: modern experiments show these geoglyphs didn't require advanced technology. By removing just a few inches of dark surface stones to expose the lighter soil beneath, the Nazca created high-contrast lines visible from low-flying aircraft. Teams attempting to recreate the process found that simple tools and careful pacing could replicate the designs, though matching their precision still proves challenging. Yet this raises another question. If the lines weren't meant to be seen from above, why bother with such exacting proportions? theories abound, from astronomical observatories to landing strips for ancient astronauts, but the most compelling evidence points to ritual walking paths. Footprints preserved near some glyphs suggest ceremonies where participants traced the shapes to commune with spirits. The act of creation may have been as sacred as the finished product, a meditative practice binding the community to the land and cosmos. Whatever their purpose, the Nazca lines remind us that human ingenuity doesn't always follow predictable paths. Sometimes the greatest mysteries aren't about how something was made, but why. Standing silent and imposing against the desert sky, the Great Pyramid of Giza holds a secret in its very foundations. An architectural precision so exact it baffles engineers even today. The pyramid's 4 base corners align almost perfectly with the cardinal directions, deviating from true north by just 3/60ths of a degree. To put that in perspective, modern architects using laser-guided tools would struggle to achieve such accuracy, yet the Egyptians pulled it off over 4,500 years ago with nothing but the naked eye and rudimentary tools. How did they manage this astronomical feat, and what does it reveal about their understanding of the cosmos? One theory points to the ancient Egyptians' mastery of celestial observation. Researchers suggest they might have used the stars as their guide, particularly a method called the simultaneous transit. By tracking the circular motion of a single star around the celestial pole, likely Polaris or Thuban, which served as the North Star in their era, they could mark its rising and setting points on the horizon. Aligning 2 of these markers would create a near-perfect north-south line. Supporting this idea are inscriptions in later temples describing ceremonies where priests stretched the cord to establish sacred alignments, hinting at a ritualized form of surveying. But here's the catch: even with this method, the margin for error would be significant, yet the pyramid's alignment is precise enough to rival modern satellite measurements. Another possibility involves the ingenious use of shadows. During the autumn or spring equinox, when day and night are of equal length, a vertical rod or obelisk casts a shadow that runs perfectly east-west at solar noon. By bisecting the angle between this shadow and a plumb line, the Egyptians could determine true north with remarkable accuracy. Experiments using replicas of ancient tools like the Merkit, a simple sighting instrument made of a palm rib and a weighted string, have shown that patient observers could achieve alignments within fractions of a degree. The secret might lie in their painstaking repetition, refining their measurements over weeks or even months. What's often overlooked is the pyramid's role as more than just a tomb. It was likely a monumental embodiment of celestial harmony. The alignment wasn't just functional, it was symbolic, connecting the pharaoh's journey to the afterlife with the eternal cycles of the heavens. The pyramid's shafts, for instance, point directly at key stars like Sirius and Orion's belt, reinforcing this cosmic blueprint. Modern attempts to replicate the pyramid's precision using ancient methods reveal something profound. The Egyptians didn't just build structures, they encoded the very fabric of their universe into stone. Yet the mystery deepens when you consider the pyramid's global counterparts. Structures like Teotihuacan in Mexico and the Moai of Easter Island also exhibit uncanny celestial alignments, despite oceans and millennia separating these cultures. Was this a case of convergent innovation, or is there a lost thread of knowledge linking these civilizations? The Great Pyramid's alignment stands as a silent challenge to our assumptions about the past, a reminder that ancient builders saw the world and the stars above with a clarity we're still striving to match. For 700 years, one weapon struck fear into the hearts of every sailor who dared approach Constantinople's mighty walls. A liquid fire so potent it clung to water, defied attempts to extinguish it, and turned entire fleets to ash. Known simply as Greek fire, this Byzantine marvel was the ancient world's most closely guarded secret. A substance so devastating its exact recipe was known only to a handful of emperors and chemists. Even today, with all our scientific advancements, we still haven't fully cracked the code of what made it burn with such relentless fury. Historical accounts describe Greek fire as a sticky, napalm-like substance launched from bronze tubes mounted on Byzantine ships. When ignited, it would explode across the waves, clinging to enemy hulls and sails, burning even as sailors desperately threw water on it. Some reports claim it grew fiercer upon contact with the sea. The terror it inspired was psychological as much as tactical. Opposing navies would scatter at the mere sight of the Byzantine siphons, knowing escape was nearly impossible once the flames took hold. So what made this ancient superweapon so potent? Fragmented texts hint at a mix of quicklime, petroleum, and pine resin, possibly thickened with sulfur or saltpeter. The quicklime would have reacted violently with water, generating intense heat to ignite the mixture on impact. But here's the twist: modern recreations based on these ingredients never quite match the descriptions of Greek fire's infamous persistence. Some scholars suspect the Byzantines might have infused it with an unknown accelerant, perhaps a distilled form of naphtha or even an early form of chemical ignition. The delivery system was just as ingenious as the fuel itself. Byzantine engineers designed pressurized bronze pumps called siphons, capable of spraying the liquid fire in arcs over 200 feet. These weren't just flamethrowers, they were precision instruments, often mounted on the prows of Droman warships and shielded by armored operators. Imagine the shock of enemy crews watching jets of fire erupt from what appeared to be decorative dragon heads, turning the sea itself into a killing field. What's most fascinating isn't just the fire's destructiveness, but the Byzantine Empire's obsessive secrecy around it. Emperors reportedly divided the formula among trusted families, ensuring no single person could Chinese letter its secrets. Captured siphons were useless without the exact mixture, and defectors who claimed knowledge were often fed disinformation. When Constantinople finally fell in 1453, the last remnants of Greek FIRES Chinese letter VANISHED with it, EITHER Chinese letter I, and the chaos or hidden in some forgotten vault beneath the city's ruins. Yet the legacy of this terrifying innovation lives on. Medieval Arab scholars wrote of their own failed attempts to replicate it, calling it naft, while crusaders brought back exaggerated tales of dragons breathing fire that inspired early European experiments with gunpowder. Today, military historians see Greek fire as a precursor to modern incendiary weapons, a reminder that the ancient world was capable of chemical warfare long before the 20th century. But perhaps the real lesson lies in the Byzantines' understanding of fear as a weapon. They didn't just invent a tool, they crafted a myth, a reputation so potent it secured their dominance for centuries without a single shot needing to be fired. Buried beneath the ruins of Mohenjo-Daro lies a network so advanced it would make any modern city planner stop and stare: the world's first organized sanitation system, built over 4,000 years ago by the mysterious Indus Valley civilization. While ancient Rome often gets credit for pioneering plumbing, these forgotten engineers were perfecting the art of water management centuries earlier, with a sophistication that wouldn't be seen again for millennia. Picture a city where every home had its own brick-lined drainage channel, where wastewater flowed through covered sewers beneath paved streets, and where terracotta pipes funneled rainwater with precision. This wasn't just functional infrastructure, it was a testament to a society that valued public health on a scale unmatched in the ancient world. The genius of Mohenjo-Daro's system lies in its details. Each house connected to a central drain running beneath the main streets, carefully sloped to ensure gravity carried waste away from living spaces. The bricks lining these channels were laid with gaps between them, acting as primitive filters to trap debris while allowing liquids to pass, a concept still used in modern septic systems. But what's truly remarkable are the flushing toilets found in upper-class homes. These weren't simple pits, but elevated platforms with wooden seats that drained into the sewer network below. Some even featured terracotta pipes with cork-like stoppers, suggesting residents could control water flow with plug and release mechanisms. Equally impressive is what archaeologists haven't found: no evidence of cesspits or open sewage in residential areas. Unlike contemporaries in Mesopotamia or Egypt, where waste often accumulated in streets, the Indus Valley people engineered their city to keep filth out of sight and out of mind. Their covered drains featured periodic inspection holes, allowing maintenance workers to clear blockages without disrupting the entire system. Recent excavations even revealed a massive Great Drain, nearly 3 feet wide, running the length of the city's main thoroughfare, a Bronze Age equivalent of a modern trunk sewer. What's puzzling is how this knowledge vanished. When the Indus civilization declined around 1900 BCE, their sanitation secrets disappeared with them. Later Indian cities reverted to simpler pit toilets, and it would take Rome another 2,000 years to develop comparable public works. Some researchers speculate the system relied on a centralized authority to maintain it. Once that social structure collapsed, the technical expertise faded. Others point to climate change drying up the region's rivers, making water management less of a priority for survivors who migrated elsewhere. Modern engineers studying Mohenjo-Daro's design have uncovered subtle brilliance in its simplicity. The uniform brick sizes across the city suggest standardized manufacturing, while the slightly convex shape of street surfaces directed rainwater into drains without erosion. There's even evidence of settling tanks where solids would separate from liquids before discharge, a primitive form of wastewater treatment. These innovations didn't just serve practicality, they reflected a profound understanding of urban living. In a time when most cultures saw disease as divine punishment, the Indus people seemed to grasp the connection between cleanliness and health. Perhaps the most haunting question isn't how they built it, but why no one else did. While Egypt poured resources into pyramids and Mesopotamia erected ziggurats, the Indus Valley invested in something far more revolutionary: a blueprint for civilized life. Their legacy isn't carved in stone or gold, but in clay pipes and careful gradients, a reminder that true progress often flows quietly beneath our feet. In the year 132, a brilliant Chinese astronomer and inventor named Zhang Heng unveiled a device that would shatter assumptions about ancient technology: a bronze vessel capable of detecting earthquakes hundreds of miles away. This wasn't just an early warning system. It was a masterpiece of mechanical intuition, designed with such elegance that modern engineers still marvel at its sophistication. The seismoscope, as he called it, stood about 6 feet tall, shaped like an ornate wine jar with 8 dragon heads circling its rim, each clutching a bronze ball above corresponding frog figurines with gaping mouths. When an earthquake struck, even faint tremors traveling through the ground would trigger a hidden internal pendulum, dislodging a single ball to drop precisely into the mouth of the frog, pointing toward the quake's origin. What makes this invention so extraordinary isn't just its detection capabilities, it's the precision with which it worked. Historical records describe how, in one famous instance, the device alerted the imperial court to an earthquake in a distant province long before messengers could arrive with news of the devastation. Critics at the time dismissed it as luck until messengers confirmed both the quake's occurrence and its direction, matching the dragon that had released its ball. Modern reconstructions have proven the mechanism's effectiveness, showing how a carefully balanced pendulum inside the vessel could respond to seismic waves with startling accuracy. Some replicas can even distinguish between different directions of tremors within a margin of error smaller than 15 degrees. The genius of Zhang Heng's design lies in its simplicity. Instead of relying on complex gears or electrical sensors like modern seismographs, it harnessed basic physics, pendulum motion, and gravity to achieve its purpose. Each dragon head was counterweighted to respond only to tremors coming from its specific orientation, while the central pendulum amplified even the faintest vibrations. The frogs weren't merely decorative. Their wide mouths ensured the balls would clang loudly on impact, creating an audible alert. This combination of form and function hints at a profound understanding of vibration dynamics, centuries before Western science began grappling with the concept. Yet the most tantalizing mystery isn't how it worked, but how the knowledge was lost. For centuries after Zhang Heng's death, later Chinese dynasties attempted to recreate the seismoscope, but none matched its reliability. The original was destroyed in one of China's many wars, and even its detailed descriptions in historical texts leave gaps, particularly around the exact mechanism linking the pendulum to the dragons. Some scholars speculate it used an ingenious system of levers or tripwires, while others propose suspended weights that would tilt with ground movement. Recent experiments using thin silk threads to trigger releases have come close, but the true secret may forever remain buried with its creator. What's often overlooked is the cultural context behind this innovation. In ancient China, earthquakes weren't just disasters, they were cosmic disturbances, signs of imbalance between heaven and earth. A ruler's mandate was tied to his ability to foresee and respond to such events, making the seismoscope as much a political tool as a scientific one. This intertwining of astrology, governance, and engineering reveals a society where innovation served multiple masters, blending practicality with philosophy. Today, as we grapple with predicting earthquakes using satellite arrays and AI algorithms, Zhang Heng's dragon-adorned vessel stands as a humbling reminder. Sometimes the most advanced solutions are also the most beautifully simple. High atop the stepped pyramids of the Yucatan, Mayan astronomers tracked celestial movements with a precision that would put modern computers to shame. While medieval Europe still struggled with a calendar that drifted out of sync with the seasons, these ancient stargazers had already calculated the solar year at 365.242 days, just 17 seconds shorter than our current measurement. Their observatories weren't just buildings, they were meticulously aligned instruments with windows and doorways framing the exact points where Venus would appear, disappear, and reappear in its complex 8-year cycle. At sites like El Caracol in Chichen Itza, the spiral tower's narrow slits align perfectly with the planet's most extreme northern and southern positions on the horizon. But the real marvel lies in their mathematics. Without telescopes or Arabic numerals, Mayan scholars developed a place value system using just 3 symbols: a shell for 0, a dot for 1, and a bar for 5. This seemingly simple notation allowed them to perform calculations into the millions and track cosmic cycles spanning thousands of years. Their long count calendar could pinpoint dates over a span of 5,125 years with unerring accuracy, a feat European astronomers wouldn't match until the invention of mechanical clocks. What's often overlooked is how these celestial observations permeated daily life. The Dresden Codex, one of the few surviving Mayan manuscripts, contains detailed tables predicting solar eclipses and the synodic periods of Mars with eerie precision. Farmers planted crops according to Venus's appearance as the morning star, while rulers timed wars to coincide with astrologically auspicious alignments. Even their mythologies reflected this cosmic precision. The hero twins of the Popol Vuh ascend to become the sun and moon, mirroring the actual celestial mechanics the Maya had mapped. Modern researchers using laser scanning technology have uncovered even more sophistication. At Capon, hieroglyphs reveal the Maya corrected their lunar calendar by subtracting a day every 499 months to account for orbital variations, a calculation requiring generations of meticulous record-keeping. Their Venus tables account for the planet's irregular motion with corrective factors that anticipate modern perturbation theory by a millennium. The haunting question isn't how they achieved this, but why their knowledge faded. As Spanish conquistadors burned codices and dismantled temples, the depth of Mayan astronomy nearly vanished. Only now, as archaeologists piece together fragments of their legacy, do we grasp the full brilliance of these sky watchers who turned pyramid steps into celestial abacuses and shadows into cosmic clocks. In an age without lenses or steel, they measured time itself with the patience of gods. For centuries, Viking longships defied the brutal North Atlantic, crossing treacherous waters to reach destinations as far as Newfoundland, all without compasses or charts. How did these legendary navigators traverse fog and endless overcast skies with such deadly precision? The answer might lie in an enigmatic tool mentioned in medieval sagas, the Solstein or Sunstone. More than just a mythical object, these crystals could have been sophisticated optical devices harnessing the physics of polarized light, giving Vikings an edge no other culture possessed until modern times. Recent experiments reveal the startling practicality behind these stones. When light passes through certain crystals like Iceland spar, a form of calcite common in Scandinavia, it splits into two beams due to birefringence. By rotating the crystal under cloudy skies, a navigator would notice subtle shifts in brightness, pinpointing the sun's hidden position with uncanny accuracy. A 2012 study published in the Proceedings of the Royal Society demonstrated this technique could determine the sun's location within 5 degrees, even after sunset or during twilight. That's precise enough to maintain a course across open ocean for days. But the real genius lies in how the Vikings might have refined this method. Unlike simple sundials, sunstones would have worked at any latitude, even during the midnight sun or polar winters when the sun skirts the horizon. Researchers at Eötvös University in Hungary reconstructed likely Viking navigation techniques using a crystal, a shadow stick, and a wooden panel with carved notches to record angles. Their findings suggest a Viking navigator could have corrected their course every 3 hours, staying on track with error margins smaller than early magnetic compasses. The archaeological record tantalizingly supports this theory. A chunk of Iceland spar was found aboard a 16th century English shipwreck in the Channel, preserved near the navigator's quarters. While not Viking era, it hints at a surviving tradition of crystal navigation long after the Norse heyday. Even more compelling are 10th century fragments of similar calcite discovered in a sunken Viking trading vessel off Alderney, though critics argue these could have been decorative. What's often overlooked is how sunstones fit into the broader Viking toolkit. They likely didn't rely on crystals alone, but combined them with wave patterns, bird behavior, and star knowledge memorized in intricate Aether poems. A 12th century Icelandic manuscript describes sailors using the sunstone to check the skies, dark blue light, when clouds deceived the naked eye. This multi-layered approach mirrors modern redundancy in navigation systems where GPS is cross-checked with inertial guidance. Yet the mystery persists. Why did this technology vanish? As magnetic compasses reached Europe in the 13th century, sunstones faded into legend, preserved only as curiosities in church reliquaries. Some historians speculate that the technique required years of training, making it vulnerable to disruption during Scandinavia's Christianization. Others suggest Iceland spar became harder to source as trade routes shifted. Today, the sunstone's legacy endures in unexpected ways. Pilots and sailors still learn to read polarized light for emergencies, while NASA has studied calcite's properties for extraterrestrial navigation. The Vikings, it seems, didn't just conquer the seas, they unlocked a hidden layer of reality, turning the very sky into a compass long before science could explain why it worked. Gliding a blackened reed along the waterline of their eyes, ancient Egyptian nobles and commoners alike were doing far more than enhancing their beauty. They were engaging in one of history's most sophisticated acts of preventive medicine. Kohl, that iconic dark eyeliner seen on everything from Tutankhamun's death mask to Nefertiti's bust, wasn't just cosmetic. Modern chemistry has revealed it functioned as a powerful antibacterial shield, protecting wearers from the blinding infections that plagued communities along the Nile. At the heart of this innovation lay an unlikely hero, galena, a lead sulfide mineral crushed into fine powder and mixed with animal fats or plant oils. While modern science warns of lead's toxicity, the Egyptians intuitively harnessed its antimicrobial properties. Studies on ancient coal samples show it sparked a chemical reaction when applied to moist skin, generating nitric oxide, a compound that boosts the immune system's ability to fight bacteria. The Nile's annual floods brought not just fertile soil, but waterborne pathogens like Chlamydia trachomatis, which causes trachoma, an eye disease still endemic in Egypt today. Coal formed a physical barrier against flies spreading infection while simultaneously medicating the sensitive skin of the eyelids. But the brilliance of coal extended beyond biology. The precise recipes varied by class and purpose, with some mixtures incorporating crushed malachite for green hues or lapis lazuli for blue, each color carrying spiritual significance. Temple inscriptions describe the Eye of Horus makeup ritual, where the application of coal was believed to ward off the evil eye and invoke the god's protection. Archaeologists have found tiny coal pots buried with children, suggesting even the youngest Egyptians were guarded by both science and superstition. The most striking evidence comes from the work of French pharmacologists who recreated ancient recipes. When tested against modern antibiotic-resistant strains like Staphylococcus, the lead-based coal proved startlingly effective, inhibiting bacterial growth at concentrations as low as 1%. This doesn't mean lead was harmless. Skeletal remains show some accumulation, but in a world without germ theory, the trade-off clearly favored its protective benefits. What makes coal truly remarkable is how it permeated every layer of society. From laborers working the fields to pharaohs entombed in gold, all shared this daily ritual. The implements themselves were works of art: exquisitely carved ivory sticks, alabaster jars with serpent designs, even portable containers hung around the neck like pendants. In a civilization that saw no divide between medicine and magic, coal became the ultimate fusion, a practical solution dressed in divine symbolism. Today, as researchers explore lead-based compounds for next-generation antibiotics, the past whispers an unexpected lesson. Sometimes the most profound innovations don't come labeled as progress, they hide in plain sight, smudged along the edges of history's eyes. Unearthed in 1908 amid the ruins of a Minoan palace on Crete, the Phaistos disk remains one of archaeology's most tantalizing puzzles. A clay circle no larger than a dinner plate, yet packed with mysteries that have defied explanation for over a century. Its surface spirals with 45 distinct symbols, from running figures to helmeted heads, each painstakingly pressed into the clay with individual stamps. Here's what stumps scholars: this isn't writing as we know it. Unlike linear A or B scripts found elsewhere in Crete, the disk symbols don't correspond to any known language, and their stamped production suggests a form of mass communication unheard of in the Bronze Age. Theories about its purpose range from the practical to the profound. Some researchers argue it's an early example of movable type, predating Gutenberg's press by 3,000 years. The consistency of the symbols, each nearly identical despite being stamped, implies a level of standardization that would revolutionize our understanding of Minoan technology. Others propose it's a religious calendar, with the spiral representing cyclical time and the symbols marking rituals or celestial events. A recent computational analysis revealed repeating sequences that mirror poetic meter, hinting it might be a hymn or invocation, meant to be read aloud in a ritual context. But the disk's true enigma lies in its isolation. No other stamped artifact like it has ever been found in Minoan ruins, not even fragments. The symbols themselves are an eclectic mix. Some resemble Minoan hieroglyphs, while others appear unique, like a peculiar, plumed head that shows up precisely 18 times. This singularity has fueled skepticism, with a few scholars even suggesting it could be an elaborate hoax, though most dismiss this given its secure archaeological context. Modern attempts to decode it using AI pattern recognition have yielded possible links to Anatolian or Luwian languages, but no definitive translation. What makes the disc so captivating isn't just the what, but the how. The precision of the stamps suggests a level of bureaucratic or artistic organization we didn't credit to the Minoans. Imagine a workshop where artisans crafted individual symbol dies, then arranged them deliberately, like a prehistoric printing press. The spiral layout itself is a marvel, starting at the edge and winding inward without a single mistake in spacing, implying the creator had the entire message planned before stamping began. Perhaps the most haunting possibility is that we're looking at a failed experiment, a lone scribe's attempt to innovate beyond clay tablets, abandoned when the technique proved impractical. Or maybe it's a royal decree, a diplomatic message for a foreign ally whose language we've yet to decipher. The Phaistos disc refuses to surrender its secrets, standing as a silent challenge at the crossroads of art, language, and technology. Every breakthrough in linguistics or computing brings fresh hope of cracking its code, but for now, it remains a whisper from the past just out of earshot. High in the Andes, where thin air meets towering stone, the Inca performed medical miracles that would stump modern surgeons, delicately drilling holes in living skulls with survival rates that put 19th century hospitals to shame. Trepanation, the ancient practice of removing sections of bone from the cranium, wasn't unique to the Inca, but their mastery of it borders on the supernatural. Archaeologists have uncovered hundreds of skulls from Peru's Cusco region, showing clear evidence of this brutal yet precise surgery, with something even more astonishing: healed edges. These weren't fatal experiments, they were successful operations, often performed multiple times on the same patient. The technical precision is staggering. Using obsidian blades and bronze tools, Inca surgeons carved clean, circular holes ranging from the size of a coin to nearly 4 inches across. Microscopic analysis reveals they avoided piercing the protective membrane around the brain, suggesting an intimate knowledge of cranial anatomy. Some skulls show multiple trepanations, each with fully healed bone growth, indicating patients survived not just once but repeatedly. Compare this to Civil War-era surgeons, whose patients faced mortality rates as high as 90% from similar procedures, and the scale of Inca achievement becomes clear. But how did they prevent infection in an era without antibiotics? The answer might lie in the high-altitude pharmacies of the Andes. Quechua healers today still use a repertoire of natural antiseptics, bark from the mole tree, which contains antibacterial compounds similar to modern disinfectants, or sap from the Sanga de Grotto tree, known to staunch bleeding and promote tissue regeneration. Ethnobotanists have identified at least 17 plants in Inca territory with proven antimicrobial properties, many of which leave chemical traces on excavated surgical tools. What's even more remarkable is the why. Unlike European trepanation, which was often crude and superstitious, Inca surgeries appear methodical. Skulls with fractures from battle or ritual combat show trepanations precisely placed to relieve swelling, evidence of systematic trauma care. Other openings align with areas where chronic conditions like epilepsy or migraines might create pressure, hinting at diagnostic skills we'd assumed were modern. The real mystery isn't just their success, but how this knowledge vanished. Spanish chroniclers dismissed Inca medicine as witchcraft, even as their own soldiers died from infections the natives could prevent. Today, neurosurgeons study these ancient skulls, searching for clues that might inspire safer techniques. In those carefully drilled holes, we don't just see surgical skill. We witness the birth of a science that flickered brightly, then was nearly extinguished by time. Tucked away in a Yale University vault lies a book that has defied comprehension for 6 centuries, a weathered manuscript filled with looping, alien script curling around illustrations of plants that don't exist, women bathing in emerald green liquid, and celestial maps charting unknown constellations. The Voynich manuscript, named after the Polish book dealer who rediscovered it in 1912, isn't just a historical curiosity. It's a cryptographic Everest, a puzzle so resistant to decoding that even World War II's top codebreakers and modern AI algorithms have thrown up their hands in defeat. What makes this 15th century artifact so maddening is its eerie coherence. The text flows with consistent patterns, suggesting real language rather than gibberish. Words repeat in predictable ways, yet defy every known linguistic structure. Statistical analysis reveals it aligns closest with natural languages like Latin or Hebrew in letter frequency, but none of the 25 proposed alphabets match its symbols. The illustrations only deepen the enigma. Delicate herbarium pages depict roots and leaves unidentifiable by botanists, while fold-out astrological diagrams show zodiac signs entangled with naked figures in impossible anatomical arrangements. Recent breakthroughs have only added layers to the mystery. In 2019, researchers using radiocarbon dating confirmed the vellum pages dated between 1404 and 1438, likely originating in northern Italy. But here's the twist. Ink analysis revealed traces of iron gall, a common medieval ink, yet the pigments in those surreal illustrations contained minerals from the New World, centuries before Columbus sailed. Some pages even glowed under ultraviolet light, hinting at lost text or secret layers. Theories about its purpose range from the plausible to the fantastical. Some scholars argue it's an elaborate Renaissance hoax, crafted to dupe a wealthy patron, yet the manuscript's complexity suggests years of labor for no clear payoff. Others propose it's a coded herbal by an alchemist, with the plants representing chemical processes rather than real flora. The most tantalizing hypothesis comes from linguists who have identified possible Semitic influences in the script's right-to-left flow, suggesting it could be a lost Judeo-Arabic dialect encrypted through visual substitution. Modern technology has brought us closer than ever to cracking the code, yet the manuscript still guards its secrets. AI trained on hundreds of languages detects grammatical structures but can't extract meaning. One team claimed to decode 10 words using Hebrew ciphers, identifying terms like farmer and light, but the full text remains locked. Even steganography, the art of hiding messages within images, hasn't yielded definitive answers, though spectral imaging reveals faint numbering systems beneath some diagrams. Perhaps the most haunting possibility is that the Voynich manuscript represents a dead end, not because it's nonsense, but because the key to understanding it has been lost to time. Without the cultural context or living speakers of its language, we might be staring at an entire world rendered inaccessible. In those cryptic curves and uncanny botanicals lies a reminder that the past isn't always a puzzle to be solved. Sometimes it's a mirror reflecting the limits of our own understanding. Beneath the waters of modern-day Tunisia lies the ghost of an engineering marvel so advanced, its secrets-fueled Rome's rise as a naval superpower, the circular military harbor of Carthage. While the Romans famously salted the earth after destroying the city in 146 BC, they couldn't resist salvaging one thing: the blueprints for this aquatic fortress. Imagine a perfect ring of stone nearly 1,000 feet in diameter, encircling an artificial island like the spoke of a wheel. This wasn't just a dock, it was a floating war machine capable of sheltering over 170 warships while hiding their numbers from prying eyes. The brilliance of Carthage harbor lay in its deception. From the sea, the entrance appeared as a narrow, unassuming channel, masking the vast inner circle where ships could be massed for surprise attacks. But the real stroke of genius was the rotating platform at the harbor's heart. Ancient sources describe a massive wooden mechanism, possibly powered by teams of slaves or even water pressure, that could spin warships to face the exit like a revolving door. This allowed the Carthaginian fleet to deploy in minutes, turning the harbor into a coiled spring ready to unleash havoc on invaders. Recent sonar scans of the site reveal even more sophistication. The inner basin's floor was lined with submerged shipyards, covered slips where vessels could be repaired or built in secret, shielded from view by the harbor's high walls. Greek historian Appian wrote of its double walls that prevented even those inside from seeing the full strength of the fleet. Modern engineers have calculated that the harbor's design created a hydraulic effect, using tidal flow to flush out silt naturally, solving a maintenance problem that still plagues ports today. When Rome finally breached Carthage's defenses, they didn't just loot gold, they reverse-engineered the harbor's innovations. Traces of its DNA appear in Rome's hexagonal Portus harbor built by Claudius, complete with a central island for rapid deployment. Yet the Carthaginians had achieved this centuries earlier without concrete or cranes, using nothing but precise stonework and an intimate understanding of hydrodynamics. Their harbor wasn't merely functional, it was psychological warfare, a statement of naval dominance that dared rivals to challenge the Mediterranean's most formidable fleet. What makes this lost technology so haunting is how little physical evidence remains. Unlike the pyramids or Roman roads, Carthage harbor survives only in fragments, a curved seawall here, a submerged foundation there. Most of what we know comes from Roman accounts written by admirers who'd once been enemies. Even in ruin, the harbor achieved its final purpose, becoming a blueprint for its destroyers, ensuring that while Carthage fell, its engineering genius would conquer the world under another name. Deep within the Temple of Hathor at Dendera, a strange relief has ignited debates that bridge ancient mysticism and modern science, a carving that, at first glance, looks uncannily like a giant light bulb. Etched into the stone around 50 BC, the so-called Dendera light depicts a serpent coiled inside an elongated, lotus-shaped vessel, stretching toward what could be filaments, all supported by a pillar resembling an insulated cable. To some, this isn't just symbolic art, it's evidence the Egyptians harnessed electricity millennia before Volta or Edison. But is this a genuine depiction of ancient tech, or are we projecting our modern worldview onto the past? The resemblance to early 20th century cathode tubes is striking. The bulb-like object's interior mirrors the dual spirals of Crookes tubes, early experimental electrical devices that produced glowing plasma when current passed through them. Even more intriguing are the figures beside the bulb. One appears to hold the object while another gestures as if adjusting a control mechanism. Proponents of the electrical theory point to the Baghdad Battery as potential corroboration, suggesting these artifacts might represent different components of a lost technological system. Modern experiments have shown that replicas of the Dendera design, when filled with gas and charged, can produce a dim glow, fueling speculation further. Yet mainstream Egyptologists offer a vastly different interpretation. The relief, they argue, is a symbolic representation of the sun god's journey through the underworld, encapsulated in the Jed pillar, a symbol of stability, and the snake in the lotus motif tied to creation myths. The filament might depict the sacred serpent Sota, an embodiment of divine energy, while the cable could be an artistic convention showing the union of earth and sky. The entire scene sits alongside other cosmological imagery, making it part of a broader spiritual narrative rather than an isolated technical diagram. The debate hinges on cultural context. Ancient Egyptian art rarely depicted real-world technology literally. Instead, it conveyed metaphysical concepts through stylized forms. Even if the carving resembles a light bulb, there's no archaeological evidence of wiring, power sources, or lenses to support the electrical theory. However, the middle ground might lie in the Egyptians' understanding of natural phenomena. Some researchers propose the relief could symbolize knowledge of bioluminescence or even electrostatic effects from polished gold and silver in dark temple chambers, effects that might have seemed magical, worthy of immortalization in sacred art. What's undeniable is the relief's enduring mystery. Unlike the Antikythera Mechanism or Roman concrete, the dendrolite leaves no physical traces to analyze, only interpretations. Modern engineers marvel at its possible parallels, while historians caution against seeing the past through contemporary lenses. Perhaps the truth isn't binary. The carving could be both a spiritual metaphor and an echo of observed natural phenomena, a reminder that ancient innovators often blurred the line between ritual and experimentation. In that ambiguity lies its real power, not as proof of lost technology, but as a testament to human creativity's boundless forms. Rising above the ancient Inca capital of Cusco, the fortress of Sacsayhuaman stands as a stone puzzle that defies logic. Its zigzagging walls are assembled from massive limestone blocks, some towering 20 feet high and weighing as much as 300 tons, yet they fit together with a precision that makes modern masons scratch their heads. The stones don't just sit atop one another, they interlock in 3 dimensions, their edges beveled and curved like pieces of a cosmic jigsaw. The result seems so tight you couldn't slip a sheet of paper between them, let alone a blade. This isn't just mortarless construction, it's architectural alchemy. What makes these walls even more astonishing is how they were built. The Inca had no iron tools, no wheeled vehicles, and no written blueprints, just bronze chisels, stone hammers, and an intimate knowledge of their materials. Archaeologists have found evidence that workers shaped each block by repeatedly dropping smaller stones onto precise points to fracture the limestone along natural fault lines. Then came the fitting process, where stones were likely rubbed together with abrasive sand until their surfaces matched perfectly. The technique, called ashlar masonry, required such patience that a single wall could take generations to complete. But here's the real genius: these walls are earthquake-proof. Peru sits on one of the most seismically active zones on Earth, yet Sacsayhuaman has weathered centuries of tremors without crumbling. The secret lies in the stone's slight flexibility and the way their irregular shapes distribute energy. During quakes, the blocks shift and settle rather than crack, a principle modern engineers call seismic isolation that's now used in skyscrapers from Tokyo to San Francisco. Some researchers believe the zigzag layout itself acts as a shock absorber, channeling seismic waves away from the structure. The deeper mystery is how the Inca transported these titanic blocks. The nearest quarry lies over 2 miles away, across steep terrain at 12,000 feet of elevation. While theories suggest they used log rollers and earthen ramps, the logistics remain mind-boggling. Recent experiments with replica stones show that even with hundreds of workers, moving a single 200-ton block would require weeks of coordinated effort. Oral histories speak of a mythical plant that softened rock, a legend some scientists now take seriously, as certain local herbs contain oxalic acid that can etch limestone. Perhaps most haunting is what these walls don't tell us. Unlike Egyptian hieroglyphs or Roman inscriptions, the Inca left no written records of their methods. Spanish chroniclers dismissed the fortress as the work of demons, unable to reconcile its sophistication with their view of indigenous peoples. Today, as laser scans reveal hidden grooves and mathematical patterns in the stonework, we're left with a humbling truth: Sacsayhuaman isn't just a relic of the past. It's a masterclass in engineering, written in a language of stone we're still learning to read. In the scorching deserts of ancient Persia, where summer temperatures could melt lead, engineers perfected a technology that defied logic: underground refrigerators capable of preserving ice through the blistering heat. These domed structures, called yakchuls, weren't just primitive coolers. They were feats of thermodynamics, harnessing the desert's own extremes to create a year-round supply of ice in one of the harshest climates on Earth. Picture a massive earthen dome rising 30 feet high, its walls 2 meters thick at the base, built from a special mortar called sarouj, a mix of sand, clay, egg whites, lime, and goat hair that dried harder than concrete. Beneath it lay a labyrinth of subterranean chambers, some reaching depths of 15 feet, where blocks of ice harvested from winter lakes or carried down from nearby mountains would remain frozen even as the desert outside baked at 120 degrees. The secret to this ancient refrigeration lay in the Yakchal's ingenious design. Above ground, the dome's shape minimized surface area exposed to the sun, while its white exterior reflected solar radiation. But the real magic happened underground. A system of qanats, those legendary Persian underground aqueducts, channeled water into the chambers, where the desert's low nighttime temperatures froze it into thick layers. Then came the wind catchers, those iconic Persian towers designed to funnel even the faintest breeze down into the structure. As air flowed over the ice, it created an evaporative cooling effect, dropping temperatures further while the thick insulation locked in the cold. The result, a natural refrigerator that could maintain below freezing temperatures without a single watt of electricity. Archaeologists studying surviving Yakchals have uncovered even more sophistication. Some feature vertical shafts that acted like thermal siphons, drawing warm air up and out while pulling cooler air downward. Others have intricate drainage systems to remove meltwater without compromising the remaining ice's stability. The ice itself wasn't just stored, it was cultivated. Workers would layer thin sheets of water at night, building up crystal-clear slabs that could be cut into blocks and transported to nobility or used to chill delicacies like falude, a rosewater-infused Persian sorbet that's still enjoyed today. Modern experiments revealed just how effective these structures were. Researchers at Yazd University recreated a small-scale Yakchal using traditional materials and techniques. Even in peak summer, the interior stayed a frosty 23 degrees Fahrenheit, cold enough to preserve not just ice, but perishable foods for months. The saruj mortar played a crucial role, its porous structure allowing just enough moisture to seep through, creating a self-regulating cooling effect as it evaporated. What's most striking about the Yakchal isn't just its functionality, but its democratization of luxury. While ice houses existed in other ancient cultures, like Rome's straw-insulated pits, Persian designs were scalable, dotting trade routes from Isfahan to Baghdad. Farmers could preserve dairy and fruit, while hospitals stored medicines. Some scholars believe this technology enabled Persia's golden age of gastronomy, where sherbets and chilled rosewater drinks became symbols of hospitality. In a land where water was more precious than gold, the Yakchal didn't just defy nature. It transformed scarcity into abundance, proving that sometimes the most revolutionary innovations aren't about conquering the environment, but learning to dance with it. High in the remote Bayan Karaula Mountains between China and Tibet, a series of mysterious stone discs may hold one of archaeology's most controversial secrets, or one of its most elaborate hoaxes. Known as the Dropa stones, these palm-sized artifacts allegedly date back 12,000 years, their surfaces etched with microscopic grooves said to spiral inward like the tracks of a vinyl record. According to a sensational story first circulated in the 1960s, these grooves aren't random markings but encoded records of an otherworldly event, the crash landing of an alien spacecraft and the stranded survivors who came to be known as the Dropa tribe. The tale begins with a Chinese archaeologist named Kai Pu Te, who in 1938 reportedly discovered 712 of these discs in a network of caves, buried alongside the remains of small, elongated skeletons with oversized skulls. The stone's spiral grooves, when examined under magnification, were claimed to reveal tiny hieroglyphic-like characters telling the story of beings from the Sirius star system whose ship crashed in the mountains. Local legends from the area speak of frail, yellow-skinned visitors who descended from the clouds long ago, adding fuel to the extraterrestrial interpretation. But here's where the story unravels under scrutiny. No credible academic institution has ever verified the existence of these discs or the skeletal remains. The original accounts trace back to dubious sources. A Russian UFO researcher named Erich von Däniken popularized the story in his book Chariots of the Gods, while the Chinese government has consistently denied any archaeological discoveries matching this description. Modern scientists who have examined similar stones attributed to the Dropa found they were nothing more than common by discs, ancient Chinese ceremonial objects with decorative carvings, often dating to the Neolithic period. The so-called microscopic writing, likely natural weathering patterns or the result of primitive tool marks, yet the mystery persists in fringe circles thanks to a handful of tantalizing details. In 1962, a team of Soviet scientists supposedly analyzed one of the discs and claimed the stone contained high levels of cobalt and other metals arranged in a way that suggested artificial manipulation. Another report alleged that the grooves, when played as an audio frequency, produced an eerie humming tone. Neither claim has been independently verified, and the original discs, if they ever existed, have vanished from the historical record. The enduring fascination with the Dropa stones speaks to a deeper human desire, the hope that our ancestors encountered something extraordinary. In the absence of concrete evidence, the line between myth and history blurs. Are the stones proof of prehistoric contact with advanced civilizations, or merely an archaeological Rorschach test, a blank slate onto which we project our fantasies of cosmic connection? Perhaps the truth lies somewhere in between, reminding us that sometimes the most compelling mysteries aren't about what we find, but what we so desperately wish to believe. While we bundle up in winter chasing drafts around modern homes, the ancient Romans lounged in togas enjoying central heating 2,000 years before it became standard. Their secret, the hypocaust, an ingenious network of hollow floors and walls that transformed entire buildings into radiant heating systems, with controls so precise they could dial in the perfect temperature like adjusting a thermostat. The hypocaust worked on principles any engineer would admire. Slaves or servants would stoke furnaces with wood or charcoal, sending hot air into the cavity beneath raised floors supported by stacks of terracotta pillars. From there, heat rose through specially designed hollow bricks lining the walls, radiating warmth evenly through rooms while smoke escaped through flues. The real stroke of genius, adjustable vents at ground level let operators regulate airflow to different sections, allowing warmer temperatures for heated plunge pools in bathhouses and gentler warmth for dining rooms. Wealthy homeowners even installed decorative vents shaped like gods to mask the system's mechanics while showcasing their luxury. Archaeologists studying sites like Pompeii's Stabian baths have uncovered hypocausts so advanced they rival modern systems. The floors used layered materials, concrete for heat retention, topped with marble or mosaic for even distribution, while hollow wall tubes called tubuli increased surface area for better heat transfer. Engineers factored in thermal expansion, leaving gaps between bricks to prevent cracking. Some villas featured dual furnaces for backup heating, proving the Romans thought about redundancy long before the concept had a name. But what's truly remarkable is how widespread this innovation was. From Britain to Syria, hypocausts appeared not just in elite villas but in public bathhouses, hospitals, and even military barracks. The baths of Caracalla in Rome could heat over 6,000 bathers daily across its sprawling complex, all fed by underground furnaces manned by teams of stokers. Modern tests show these systems maintained steady temperatures around 80 degrees Fahrenheit even in freezing weather, a comfort level many older homes still struggle to achieve today. The sophistication didn't end with physics. Romans understood psychology too. They built furnaces away from living spaces to avoid noise and smoke, while floor temperatures were calibrated for barefoot comfort. Pliny the Younger wrote of his seaside villa's hypocaust with pride, noting how its gentle heat spared his guests the barbaric shivering of lesser homes. Yet after Rome's fall, this knowledge evaporated in Europe for centuries. Medieval castles reverted to smoky hearths, and the hypocaust became a forgotten relic until the industrial age rediscovered radiant heating. Perhaps the most humbling lesson lies in the system's efficiency. Unlike modern forced air heating that wastes energy warming empty spaces, hypo-costs heated surfaces, people touched floors to walk on, walls to lean against. Today's green architects are revisiting these principles, studying Roman designs to slash energy use. In those dust-filled underground channels, the past holds a surprise, not just a marvel of engineering, but a blueprint for a more sustainable future. In the dusty hills of California's Coso Mountains, a seemingly ordinary rock split open in 1961 to reveal something that shouldn't be there: a porcelain cylinder with a metal rod down its center, encased in what appeared to be 500,000-year-old sediment. Dubbed the Coso artifact, this object looks uncannily like a 20th century spark plug, complete with threaded fittings. But here's the catch: according to standard geological dating, the layers surrounding it formed long before humans mastered fire, let alone internal combustion. Was this proof of a lost industrial civilization, or is there a more down-to-earth explanation? Those convinced it's an out-of-place artifact point to its striking resemblance to early 1900s spark plugs, particularly the Champion brand used in Ford Model Ts. The outer shell is hardened clay or porcelain, while the central metal component shows signs of corrosion consistent with iron or steel. X-rays even reveal a tiny spring-like structure inside, adding fuel to the mystery. If authentic, this would imply either an unimaginably ancient technological society or time travelers leaving behind automotive debris, both scenarios straight out of science fiction. Geologists, however, offer a different perspective. The rock encasing the object isn't sedimentary layers formed over millennia, but a concretion, a hard, compact mass that can form rapidly around a foreign object when minerals in groundwater precipitate and cement together. Similar formations are found around fossils, shipwrecks, and even modern trash in riverbeds. The Coso Mountains are rich in such nodules, often forming around prehistoric fossils or mineral deposits. Laboratory analysis suggests the artifact's host material likely hardened within the last few centuries, not hundreds of thousands of years. Further scrutiny reveals another twist. The internal metal pin isn't a perfect match for vintage spark plugs. It lacks the side electrode typical of early 20th century designs. Instead, some metallurgists propose it could be the remains of a mining tool or survey equipment from the region's 19th century gold rush, enveloped by natural cementation within decades. Others note that the porcelain's composition resembles early electrical insulators used in telegraph lines, which would place its origin squarely in the 1800s. What makes the Coso artifact so fascinating isn't just the debate, it's how perfectly it encapsulates the clash between imagination and evidence. For creationists, it's a smoking gun challenging established timelines. For scientists, it's a textbook example of how natural processes can mimic the extraordinary. The truth may lie somewhere in between, not an ancient spark plug, but a testament to how quickly the Earth can fossilize the mundane into the mysterious. In that weathered lump of stone, we don't just see a puzzle. We see our own eagerness to reshape the past into something far more electrifying than reality. Standing alone on the windswept plains of Bolivia's high-altitude desert, the Gate of the Sun isn't just a monument, it's a celestial cipher carved from a single block of andesite weighing over 10 tons. This towering relic of the ancient Tiwanaku civilization, dating back nearly 1,500 years, is etched with intricate iconography that has baffled scholars for centuries. At first glance, the central figure resembles a sun god radiating jagged rays, surrounded by enigmatic winged beings and geometric patterns. But look closer, and you'll notice something extraordinary. The entire composition functions as a sophisticated astronomical calendar, tracking time in ways no other culture envisioned. The gate's most startling feature is its proposed 20-month calendar, a system unlike any recorded in history. While the Gregorian calendar divides the year into 12 months and the Maya used 18, the Tiwanaku glyphs suggest a division of 20, each marked by distinct symbols along the gate's lower frieze. Researchers have noticed these markers align perfectly with the rising and setting positions of the sun during the solstices and equinoxes, as if the stone itself were a giant sundial. During the winter solstice, sunlight pierces the gate's central arch at dawn, illuminating specific carvings that may have signaled ceremonial dates or agricultural cycles. Such precision implies an intimate knowledge of Earth's axial tilt, long before telescopes or modern mathematics existed. What's even more remarkable is how the gate's carvings double as a cosmic map. Certain figures cluster in groups of 11, possibly representing the 11-year cycles of sunspot activity, a phenomenon modern astronomy only began tracking in the 1700s. Other glyphs mirror constellations visible from the southern hemisphere, including the Southern Cross and the dark cloud constellations of the Milky Way revered by Andean cultures. Archaeoastronomers using 3D modeling have found that the gate's sightlines frame key stars during celestial events, suggesting it wasn't just a calendar but an observatory carved in stone. The mysteries multiply when you consider the gate's construction. Andesite, the volcanic rock used, is notoriously difficult to carve, yet the Tiwanaku artisans achieved razor-sharp edges and symmetrical designs without metal tools. Nearby quarries reveal abandoned monoliths with identical markings, hinting at a standardized system of measurement or ritual replication. Some theorists propose the gate was once part of a larger complex, its alignment synchronizing with other structures to form a vast celestial clock. Spanish chroniclers recorded indigenous oral histories describing the gate as a portal where priests communed with celestial beings, further blurring the line between science and spirituality. But the most tantalizing question isn't how the Tiwanaku built it, it's why their system vanished. Unlike the Maya, whose calendar traditions survived in part through codices, the Tiwanaku left no written records. By the time the Inca rose to power, the gate was already ancient, its meaning fading into myth. Today, as astrophysicists collaborate with Aymara elders to decode its symbols, the gate whispers of a time when humanity measured the heavens not in pixels or equations, but in stone and shadow. In those weathered carvings, we don't just see a calendar, we glimpse an entire cosmology, waiting patiently for the next civilization to read the stars as they did. Towering over visitors in Delhi's Qutub complex stands a silent sentinel of ancient metallurgical genius, a 23-foot iron pillar that has defied rust for 16 centuries. While modern steel bridges flake and corrode within decades, this 1600-year-old monument remains pristine, its surface smooth and uncorrupted by time. The secret, a revolutionary forging technique that baked phosphorus into the iron at levels 3 times higher than modern standards, creating a protective barrier against oxidation so effective that scientists only unraveled its chemistry in the late 20th century. What makes this 4th century innovation so extraordinary is how it challenges everything we thought we knew about ironworking. Medieval India's blacksmiths, working without blast furnaces or precision instruments, somehow mastered a process called microbial slag inclusion. Instead of removing impurities, they intentionally incorporated phosphorus-rich slag from the smelting process into the metal matrix. This created a thin, self-repairing layer of mesawite, a crystalline compound that forms when phosphorus reacts with oxygen and moisture, essentially sealing the iron off from further corrosion. Modern metallurgists attempting to replicate this effect in labs found the balance incredibly delicate. Too much phosphorus makes iron brittle, yet the Delhi pillar's creators hit the perfect ratio of 1% phosphorus to 99% iron. The pillar's durability isn't its only marvel. Its very construction defies the technological limits of its era. Weighing over 6 tons, it was likely forged in a series of small furnaces, with individual iron pieces welded together so seamlessly that the joins are nearly invisible. Ancient texts refer to such pillars as rustless wonders, suggesting this wasn't a one-off accident but a controlled technique. recent laser scans revealed even more sophistication. The pillar's surface bears microscopic grooves that may have been intentionally crafted to distribute stress and minimize cracking, a technique akin to modern stress relief patterning in aircraft metals. Perhaps most intriguing is how this knowledge slipped through history's fingers. While European ironworkers struggled with brittle, corrosion-prone metal well into the Industrial Revolution, India's rust-resistant methods faded after the 12th century. Some scholars link this to the decline of the Gupta Empire, whose artisans may have guarded the formula as a state secret. Others speculate that shifting trade routes made the specific phosphorus-rich ores from central India harder to source. Today, the pillar stands as both a monument and a mystery, its rustless surface silently mocking our assumptions about ancient innovation. Modern engineers now study its chemistry for applications ranging from earthquake-resistant rebar to marine-grade steels, proving that sometimes the most advanced solutions are hidden in plain sight, forged not in Silicon Valley labs, but in the fires of a 6th-century smithy. Deep in the rugged mountains of Qinghai Province, China, a series of bizarre iron pipes protrude from the walls of Mount Baigong's caves like the fossilized veins of some ancient machine. These rust-colored tubes, some as wide as a foot in diameter and others no thicker than a toothpick, weave through solid rock in patterns that defy easy explanation. Discovered in the late 1990s by hikers exploring the remote region, the pipes have ignited a firestorm of debate. Are they the remnants of an advanced prehistoric civilization, or merely a geological oddity that fooled the human eye into seeing design where none exists? What makes these pipes so controversial is their composition and placement. Laboratory analysis reveals they contain not just iron, but an unusual mix of silicon dioxide and calcium oxide materials consistent with industrial smelting rather than natural mineral deposits. Some pipes run horizontally into the mountain, while others plunge vertically into the earth like ancient boreholes. Most puzzling of all are those that extend into a nearby saltwater lake, suggesting a possible hydraulic function. The pipe's age adds another layer of mystery. While initial dating suggested they could be as old as 150,000 years, far predating known human metallurgy, later studies using more precise methods narrowed the timeline to between 5,000 and 8,000 years ago, still millennia before ironworking became widespread in China. Geologists offer a compelling counterargument. These might be examples of iron pipe formations, a rare but natural phenomenon where mineral-rich groundwater seeps into cracks and fissures, leaving behind iron oxide deposits as the water evaporates. Over millennia, these deposits can harden into hollow tubes that eerily resemble manufactured pipes. Similar formations exist worldwide, like Utah's sand pipes or the tubular concretions found in New Zealand's Moeraki boulders. The Baigong pipe's straight lines and right angles could be the result of jointing patterns in the bedrock, creating preferential pathways for mineral deposition. Yet some details resist easy dismissal. Certain pipes feature perfectly uniform diameters along their lengths, a consistency rare in natural formations. Others contain what appears to be deliberate welding marks, and one fragment reportedly had a microscopic structure resembling modern cast iron. Local legends speak of an ancient civilization that built flying machines, fueling speculation about extraterrestrial involvement among fringe researchers. More grounded theories propose they could be the work of the Kijia culture, a Neolithic people known for early copper use, though nothing in the archaeological record suggests they had iron technology. The truth might lie somewhere between wonder and geology. While the pipe's origins remain contested, their cultural impact is undeniable. They've become a pilgrimage site for those who believe history needs rewriting, and a cautionary tale for scientists about how easily nature can mimic human handiwork. Whether artifacts or accidents, the Baigong pipes challenge us to question the boundaries between the natural world and the fingerprints of lost civilizations, reminding us that sometimes the most alluring mysteries aren't about what we find, but what we're willing to see. Imagine walking up to a temple in 1st century Alexandria, and before you even touch them, the massive bronze doors swing open as if moved by unseen hands. This wasn't magic, it was engineering genius. Heron of Alexandria, the ancient world's answer to Leonardo da Vinci, designed the first known automatic doors using nothing but steam power, counterweights, and a healthy dose of ingenuity. Hidden beneath the temple's altar, a carefully hidden fire heated water in a sealed chamber, creating steam that flowed through pipes into a series of weights and pulleys. As the steam expanded, it triggered a system of ropes and axles that slowly pulled the doors apart, creating the illusion of divine intervention for worshippers approaching the sacred space. What makes Heron's design so groundbreaking isn't just the theatrics, it's the precision. His writings describe a counterweight system that allowed the doors to open and close at a controlled pace, avoiding the sudden, jarring movement you might expect from primitive mechanics. The steam wasn't just raw power, it was carefully regulated with vents to release excess pressure and prevent explosive mishaps. The entire mechanism was modular too, meaning priests could adjust the timing based on ceremonial needs. Faster openings for grand processions, slower for solemn rituals. This wasn't a parlor trick, it was programmable automation, centuries before the word robot even existed. Modern engineers have recreated Heron's system using his original specifications, and the results are startling. Even with today's materials, replicating the door's smooth operation is no small feat. The secret lies in the weighted spheres hidden inside hollow pillars flanking the entrance. As steam pressure built, it forced these spheres to descend, pulling chains that rotated the door's central axle. When the fire died down, the weights returned to their original position, closing the doors just as gracefully. No electricity, no motors, just physics harnessed with elegant simplicity. But here's the twist: Heron's doors might not have been a one-off marvel. Fragments of similar mechanisms have been found near Roman bathhouses and wealthy estates, suggesting automatic doors may have been more widespread than we thought. Some historians speculate that the famous, miraculous doors of ancient myths, like those said to open for heroes favored by the gods, were actually clever engineering repackaged as divine spectacle. Heron himself wrote about using automation to inspire awe, proving that even in antiquity, technology and theater went hand in hand, the real tragedy. This innovation vanished for millennia. When Rome fell, Heron's manuscripts were scattered or destroyed, and the knowledge of steam-powered mechanics faded until the Industrial Revolution. Imagine how history might have changed if those temple doors had been recognized not as a curiosity, but as the birth of automation. Today, as sensor-activated doors slide open at every supermarket, we're not witnessing modern invention. We're rediscovering an idea that's been waiting patiently in the ashes of Alexandria's temples for 2,000 years. Hidden beneath the rolling hills of Zhejiang Province, China, lies an underground labyrinth so vast and precise it defies all logic of ancient engineering, the Longyu Caves. Discovered by accident in 1992 when a curious villager drained a local pond, these 24 hand-carved caverns sprawl across 30,000 square meters, their walls chiseled with such geometric perfection that they look like the work of laser-guided machines rather than Iron Age tools. Every surface, from the towering 40-foot ceilings to the supporting pillars and staircases, bears uniform striations, a telltale sign of systematic, large-scale labor. But here's what stuns archaeologists. Based on the density of the sandstone and the volume of removed rock, creating just one of these caves would have required 1,000 workers laboring non-stop for 6 years. Yet there's no historical record, no tools, not even a single pottery shard left behind by the civilization that undertook this colossal project over 2,000 years ago. The precision of the cave's construction borders on the supernatural. walls intersect at near-perfect 90-degree angles, with chisel marks running in unbroken parallel lines across vast expanses. Pillars are spaced with mathematical consistency to distribute weight, and intricate carvings of horses, fish, and celestial patterns adorn certain chambers, each stroke mirroring the next as if stamped by a machine. Modern engineers have attempted to recreate the techniques using replicas of ancient tools, only to find that maintaining such uniformity across soft sandstone without modern measuring devices is nearly impossible. The slightest deviation in hammer strikes would have caused irregular grooves, yet the Longyu walls show no such errors. Some researchers speculate the builders used a forgotten system of templates or string guides, while others propose they mixed water with abrasives to erode the rock into precise shapes. Even more puzzling is the cave's purpose. Unlike other ancient underground complexes like Malta's hypogeums or Egypt's tombs, the Longyu caves lack burial remains, religious iconography, or signs of habitation. Their layout suggests something far more utilitarian: sloping floors that channel water toward drainage pits, ventilation shafts aligning with seasonal wind patterns, and acoustics designed to amplify sound in specific chambers. Could they have been subterranean quarries, hiding the evidence of their own construction by repurposing removed stone elsewhere? Local legends speak of an emperor seeking an underground palace, while fringe theorists propose connections to lost mining operations or even flood control systems. The most compelling clue might be in the cave's alignment. Several entrances point directly toward the constellation Draco as it appeared in 2000 BCE, hinting at possible astronomical significance lost to time. What haunts researchers isn't just the scale of the achievement, it's the silence surrounding it. China's meticulous dynastic records mention irrigation projects and great walls, but not a word about thousands of laborers carving mountains from the inside out. No tools, no waste piles, no worker settlements have ever been found nearby. It's as if the caves were built in secret, or perhaps by a culture that left no other trace. Today, as laser scanners map the caverns' hidden passages and submerged chambers, one truth becomes clear: the Longyu caves aren't just a marvel of ancient engineering. They're a riddle wrapped in stone, waiting for the right key to turn. The high-altitude ruins of ancient Peru hold evidence of a medical practice so advanced it borders on the miraculous. Skull surgery performed with such precision that patients not only survived but returned for multiple procedures. While trepanation, the drilling or cutting of holes into the skull, existed in other ancient cultures, the Andean civilizations elevated it to an art form. Archaeologists have uncovered hundreds of crania, some with perfectly circular openings as wide as a teacup, others with rectangular sections removed like puzzle pieces. The edges of these openings show smooth, healed bone growth, proving these weren't experimental hacks but carefully planned operations with long-term survival rates that would impress modern neurosurgeons. What sets Andean trepanation apart is its sheer variety and adaptability. In the highlands around Cusco, Inca surgeons preferred a scraping technique, using obsidian blades to gradually wear down the bone in concentric circles, minimizing the risk of penetrating the protective dura mater beneath. Meanwhile, coastal Paracas cultures opted for precise cutting, creating geometric flaps that could be replaced after surgery, some even secured with gold plates hammered thin as foil. These metal implants aren't just decorative. Microscopic analysis reveals they were molded to fit individual skull contours, acting as both protection and a primitive form of antiseptic barrier, since gold resists bacterial growth. One remarkable skull from the Huari culture shows 5 separate procedures over a lifetime, each healed flawlessly, suggesting these weren't desperate last resorts but part of an established medical tradition. The tools discovered at these sites reveal even more sophistication. Andean surgeons used tumi knives with curved bronze blades for clean incisions, along with bone awls and obsidian lancets sharp enough to cut human hair lengthwise. But the real genius might lie in what didn't leave traces: the anesthesia and antiseptics. While no written records survive, modern ethnobotanical studies point to a pharmacopoeia of coca leaves for numbing, chicha corn beer for sedation, and balsam-scented herbs like munya with proven antimicrobial properties. Experimental archaeologists have recreated these procedures using period-accurate tools and plant medicines, finding patients could remain conscious yet pain-free during operations lasting hours. Perhaps most astonishing are the reasons behind these surgeries. While some skulls show operations performed to treat fractures likely from sling stones or mace blows in battle, others have no visible trauma. This suggests trepanation was also used for conditions we'd now recognize as epilepsy, migraines, or mental illness. The placement of holes corresponds with areas where modern neurosurgery relieves intracranial pressure, hinting at an empirical understanding of brain physiology. One theory even proposes that the Incas viewed the skull as a container for the soul, and that opening it released evil spirits causing disease, a spiritual solution backed by astonishing technical skill. The legacy of these surgeries lingers today in unexpected ways. Neurosurgeons studying Andean techniques have adapted aspects of their gradual bone-scraping method for certain delicate procedures, while the gold plate implants foreshadow modern titanium mesh used in cranial reconstruction. In remote Quechua communities, some healers still practice a form of ritual trepanation using glass shards and herbal poultices, preserving threads of knowledge that stretch back millennia. These ancient practitioners didn't just survive their harsh environment, they mastered it, turning human bone into a canvas for some of history's most audacious medical experiments. Their work stands as a testament to innovation forged not in gleaming labs, but in the shadows of the Andes, where desperation and ingenuity collided to rewrite the limits of the possible. Among the treasures unearthed in the ruins of Nimrud, one small object stands out not for its gold or gems, but for its startling resemblance to a piece of modern technology, a rock crystal disc, ground into a slightly oval shape with one flat side and one gently convex. Dubbed the Nimrud lens, this 3,000-year-old Assyrian artifact could easily be mistaken for a magnifying glass or even a primitive telescope lens. Measuring just under 1.5 inches across, it's hardly imposing, yet the debates surrounding its purpose have sparked controversies that bridge archaeology, optics, and the history of science. Was this a decorative inlay, a fire-starting tool, or evidence that the ancient Assyrians were peering at the stars with magnified vision millennia before Galileo? Optical testing has only deepened the mystery. When researchers shone light through the lens, they discovered it has a focal point roughly 4.5 inches away, capable of magnifying objects by roughly 3 times. That might not sound impressive compared to modern telescopes, but for its time, it would have been revolutionary. The convex side is surprisingly well polished, with a consistent curvature that suggests intentional shaping rather than accidental wear. Even more intriguing, the lens is made of rock crystal, a material the Assyrians prized for its clarity and rarity, often reserving it for objects of great importance. If this were merely a decorative piece, why go to such lengths to grind it into a shape with demonstrable optical properties? Of course, skeptics have their arguments. The lens was found among a hoard of glass and crystal ornaments, leading some archaeologists to suggest it was nothing more than an inlay for furniture or a ritual object. Others propose it was used as a burning glass, focusing sunlight to ignite sacred fires, a practice known in other ancient cultures. But here's the catch: while the lens can concentrate light, its focal length is unusually long for such a purpose. A simpler, thicker piece of glass would have been far more practical for starting fires. The precision of its curvature hints at something more deliberate, something requiring a nuanced understanding of light. The most tantalizing theory connects the lens to the Assyrians' well-documented astronomical prowess. Clay tablets from the same period reveal meticulous records of celestial events, including the movements of planets and stars. Could this lens have been part of a larger optical device, perhaps mounted in a wooden or metal frame to create a rudimentary telescope? Without additional components, we can't say for sure, but the idea isn't as far-fetched as it seems. The ancient Greeks wrote about seeing tubes used to observe distant objects, and even Galileo's first telescopes were crude by modern standards. If the Assyrians had stumbled upon the basic principles of magnification, it's plausible they could have applied them to stargazing. Modern attempts to replicate the lens only add fuel to the debate. Engineers using traditional grinding techniques found that achieving the same curvature requires skill and patience, suggesting the original craftsmen knew exactly what they were doing. When mounted in a simple frame, the lens can indeed resolve details too small for the naked eye, like fine cuneiform script or distant birds in flight. It's not enough to spot Jupiter's moons, but it could certainly enhance observations of the night sky. Ultimately, the Nimrod lens remains an enigma, a whisper of possibility from a civilization that left few clues about its scientific ambitions. Whether it was a magnifying glass, a sacred object, or part of an early telescope, it challenges our assumptions about how and when humanity first harnessed the power of lenses. In that polished sliver of crystal, we see not just a tool, but a glimpse of a lost chapter in the story of discovery. One where the boundaries between art, science, and the divine blur into something extraordinary. For centuries, the towering Moai statues of Easter Island have stirred one persistent question: how did a civilization without wheels or heavy machinery transport these colossal stone figures across miles of rugged terrain? The traditional answer involved log rollers and ropes, with teams of laborers slowly dragging the multi-ton monoliths horizontally. But recent experimental archaeology has turned this assumption on its head, revealing a far more ingenious method: the statues might have walked. The radical theory emerged from a simple observation: many abandoned moai along ancient roads lie face down, as if they toppled forward mid-journey. Coupled with the statue's distinctive forward-leaning design and center of mass, researchers began questioning whether they were ever dragged at all. In 2012, a team led by archaeologists Terry Hunt and Carl Lipo conducted a groundbreaking experiment. Using a precise three-dimensional replica carved from concrete, they demonstrated how just 18 people could maneuver a 10-foot-tall moai upright with nothing but 3 sturdy ropes. One team pulled forward to tilt the statue, while 2 others steadied it from behind, creating a controlled rocking motion that made the figure appear to walk in short, rhythmic steps. The process, when synchronized, allowed the moai to advance nearly 100 yards in under an hour, effortlessly navigating uneven ground that would have snagged log rollers. But the real stroke of brilliance lies in the statue's own design. Their curved bases and sloped profiles aren't just artistic choices, they're functional engineering. Like a refrigerator being tilted to roll on its edge, the moai's shape allowed rocking with minimal friction. Oral histories collected by early European visitors suddenly made sense. Rapa Nui elders had long spoken of the statues moving with mana, or spiritual energy. What outsiders dismissed as myth may have been a coded description of this very technique. Critics initially dismissed the walking theory, pointing to roads lined with crushed rock that seemed to support dragging. Yet closer inspection revealed these paths weren't worn flat. They bore telltale pits and grooves consistent with vertical impacts, like a statue's base striking the ground repeatedly. Laser scans of moai bases even show abrasion patterns matching a rocking motion rather than horizontal scraping. The implications rewrite more than just transportation methods. If the Rapa Nui people moved their moai upright, it suggests a society deeply attuned to physics and collaboration. Unlike log rolling, which required vast amounts of timber, a resource famously scarce on Easter Island, walking used minimal materials. Just ropes woven from resilient how bark. This efficiency paints a picture of a culture far more sustainable than the ecocidal narrative often imposed on them. experiments continue to refine the technique, with teams testing larger replicas and variable terrain. Each trial reveals new nuances, how slight twists of the ropes can steer the statues, or how chance might have synchronized movement. What began as a challenge to conventional wisdom has blossomed into a tribute to human ingenuity. The Moai didn't just stand sentinel over Easter Island. They danced across it, one deliberate step at a time. In the vaults of Istanbul's Topkapi Palace lies a fragment of parchment that has ignited one of cartography's fiercest debates, the Piri Reis Map of 1513. At first glance, it appears to be just another early Ottoman naval chart, filled with swirling compass roses and annotations in elegant Arabic script. But look closer and you'll spot something impossible: the coastline of Antarctica, drawn with shocking accuracy, 300 years before the frozen continent was officially discovered. What makes this detail even more baffling is that the map shows Antarctica not as we know it today, buried under miles of ice, but as a landmass with flowing rivers and ice-free shores, a sight no human eyes had witnessed since before the last ice age. The map's creator, Ottoman admiral and cartographer Piri Reis, never claimed the work as entirely original. His notes describe compiling it from 20 source maps, including ancient Greek and Portuguese charts, and even references a mysterious map from the time of Alexander the Great. This admission has fueled speculation about lost ancient knowledge, perhaps remnants of advanced seafaring civilizations like the Minoans or Phoenicians who explored farther than we ever imagined. The most striking section shows what appears to be Queen Maud Land, an Antarctic region that wouldn't be properly mapped until modern seismic surveys in the 1950s. Even more astonishing, the map's proportions align with advanced mathematical projections, accounting for the curvature of the Earth in ways Renaissance cartography shouldn't have mastered. Mainstream scholars offer a different interpretation. Some argue the landmass labeled Antarctica is actually a distorted version of South America's eastern coast, a common error in early maps where unexplored regions were often speculative. Others note that the map lacks critical details like the Drake Passage or the Antarctic Peninsula, suggesting coincidence rather than preternatural knowledge. The ice-free depiction could stem from misinterpretations of foggy coastlines or even confusion with Terra Australis, a mythical southern continent drawn on maps since Ptolemy's time. Yet modern comparisons are hard to dismiss. When overlaying the Piri Reis map with satellite-derived reconstructions of Antarctica's ice-free topography, last seen roughly 6,000 years ago, the coastlines show eerie similarities. The map also includes mountain ranges roughly where radar has revealed subglacial peaks, like the Gambetsev Mountains buried under 2 miles of ice. Could Piri Reis have accessed records from an ancient seafaring culture with knowledge predating glaciation? Or does this simply reflect the human tendency to see patterns where none exist? The debate took a scientific turn in 1960 when cartographer Charles Hapgood proposed the map's accuracy required aerial perspectives, fueling wild theories about prehistoric advanced civilizations or even extraterrestrial influence. While most academics dismiss this, Hapgood's work did reveal something tangible. The map employs an advanced equidistant projection centered on Cairo, a technique that shouldn't have existed before the 18th century. Recent studies using geospatial software confirm that the map's errors align with distortions caused by copying older charts onto new parchment, hinting at layers of accumulated knowledge rather than a single miraculous source. Perhaps the truth lies somewhere in between. The Piri Reis map might not prove ancient Antarctic exploration, but it undoubtedly captures fragments of lost wisdom, celestial navigation techniques passed down by Arab sailors, forgotten Portuguese discoveries, or even surviving scraps of Alexandria's legendary library. In its faded ink, we see the ghostly outline of history's gaps, reminding us that the past is always more mysterious than the stories we tell about it. While the Antikythera Mechanism rightfully claims the spotlight, it wasn't the only marvel of Greek engineering blurring the line between art and algorithm. Tucked away in museum archives and private collections lie smaller, equally ingenious devices prove that the Greeks didn't just stumble upon mechanical genius once, but cultivated an entire tradition of precision machinery. Take the portable sundial recovered from a Roman shipwreck off the island of Antikythera itself, a palm-sized bronze disc that functioned as the ancient world's equivalent of a GPS-enabled smartwatch. This wasn't just a timepiece, it was a multifunctional travel companion. The sundial's intricate face featured adjustable rings calibrated for different latitudes, allowing merchants and soldiers to accurately tell time anywhere from Alexandria to Rome. Tiny geared mechanisms inside could account for seasonal changes in the sun's path, while some versions even included a built-in compass. Archaeologists studying the device found markings so precise they could track hours down to intervals of 15 minutes, a level of accuracy most medieval clocks couldn't match. What's truly remarkable is how these sundials democratized timekeeping. Unlike stationary public sundials, these were personal devices, suggesting a society where punctuality and scheduling mattered even in daily life. Then there's the crown jewel of Greek astronomical tools, the astrolabe. Often overshadowed by the Antikythera's complexity, these handheld computers were no less revolutionary. Imagine a circular bronze plate etched with overlapping rotating discs, each marked with celestial coordinates and calendar dates. By aligning specific components with observed stars, users could calculate everything from the time of sunrise to the optimal planting dates for crops. The earliest surviving example, the Naples astrolabe from the 2nd century BCE, features a retere, a delicate cut-out star map that rotates to simulate the night sky's movement. But here's what sets Greek designs apart. Many incorporated lunar phase indicators and planetary positions, essentially condensing an entire observatory's functionality into something that could fit in a scholar's satchel. Recent discoveries have only deepened our appreciation for their sophistication. In 2019, researchers using reflectance imaging on a corroded bronze fragment from Cyprus uncovered hidden gear teeth beneath the patina, revealing what appears to be a miniaturized calendrical device. Unlike the Antikythera's interlocking gears, this mechanism used a unique spiral gear system to track the metonic cycle, a 19-year period after which moon phases repeat on the same calendar dates. The complexity packed into this fist-sized object suggests these weren't rare luxuries, but part of a broader culture of mechanical innovation. Even literary hints support this. Cicero wrote about a device brought to Rome by Archimedes that could model planetary motions, while Hero of Alexandria described automated theaters using gear systems eerily similar to those in the Antikythera. What ties these devices together isn't just their craftsmanship, it's their philosophical underpinnings. The Greeks saw the cosmos as an orderly system governed by mathematical laws, and these machines were physical manifestations of that belief. Unlike later European clockmakers who focused on timekeeping alone, Greek engineers embedded entire worldviews into bronze, creating tools that didn't just measure reality but mirrored its underlying harmony. Yet for all their brilliance, these devices raise a haunting question. How much have we lost? The Antikythera survived by sheer chance, protected in a shipwreck's debris. How many other marvels, perhaps even more advanced, crumbled to dust in library fires or metal smelters? Each surviving fragment whispers the same truth. The ancient world's technological landscape was far richer, far more daring than our history books ever hinted. These weren't just tools, they were testaments to humanity's timeless drive to hold the universe in our hands, one gear at a time. Scattered across the jungles and river deltas of Costa Rica lie over 300 stone spheres so perfectly round they defy belief. Some as small as a baseball, others towering taller than a man and weighing 16 tons. Discovered in the 1930s when United Fruit Company cleared land for banana plantations, these enigmatic orbs have puzzled archaeologists for decades. Carved from hard volcanic rock like granodiorite without metal tools, their surfaces are polished to a mirror-like smoothness, with deviations from perfect roundness measuring less than 2 millimeters, a precision that would challenge modern sculptors with laser-guided tools. The mystery of these spheres isn't just how they were made, but why. Local legends speak of them as relics from the gods or as navigational aids for celestial beings, but archaeologists propose more grounded theories. Some clusters align with celestial events. Groups near Pommer Sur form straight lines pointing to magnetic north, while others may have marked solstice sunrises. Their arrangement often suggests ceremonial spaces like the stone circles of Europe, yet no two sites follow the same pattern. The most striking examples were found atop mounds or near burial sites, hinting at their use as status symbols for elite families or markers of sacred ground. Unraveling the production process only deepens the intrigue. Researchers believe the ancient Dikwis culture, who crafted these spheres between 400 and 1500 CE, used a combination of meticulous pecking and grinding. First, raw boulders were shaped using smaller stones as hammers, then smoothed with abrasive sand over months or even years. Experiments show this technique could achieve near-perfect roundness through a simple but brilliant method, suspending the sphere in a net and rotating it while workers systematically chipped away high spots. The final polish likely involved wet clay mixed with fine quartz, acting as a prehistoric sandpaper. But here's what's truly astonishing: these spheres weren't quarried locally. Some were transported over 50 miles through dense rainforest and across rivers without wheels or draft animals. The logistics boggle the mind. How did they move 16-ton stones without leaving behind the sledges or ramps we've found at other megalithic sites? One theory suggests they may have rolled them on log rails, while indigenous oral histories describe wooden levers and woven palm fiber ropes. Recent LiDAR scans have revealed hidden pathways in the jungle, possibly ancient transport routes now swallowed by vegetation. The greatest enigma lies in their sudden abandonment. When Spanish colonizers arrived in the 16th century, the spheres were already relics, their purpose forgotten. Many were vandalized or dynamited by plantation workers, while others sank into marshes, preserved like time capsules. Today, UNESCO protects the remaining clusters, yet they refuse to surrender their secrets. Modern laser scans reveal subtle markings, faint carvings of animals or celestial symbols that hint at a deeper language we've yet to decipher. Perhaps the most compelling theory isn't about function, but philosophy. The sphere's flawless forms may embody a world view where geometric perfection bridged Earth and cosmos. In their silence, they whisper of a culture that measured prestige not in gold or war, but in patience and precision. A civilization that turned mountains into mathematics, one slow tap of stone against stone at a time. High on the walls of an Assyrian temple in Nineveh, a 2,700-year-old carving depicts what appears to be a startling anachronism, a winged object with a distinctly modern silhouette, complete with a tapered fuselage, vertical tail fin, and what some claim are even propeller blades. Known as the Baghdad aircraft relief, this enigmatic artifact has fueled speculation that ancient civilizations either witnessed advanced flying machines or possessed aerodynamic knowledge lost to history. At first glance, the resemblance to a 20th century aircraft is uncanny. The central body curves like a streamlined cockpit, the delta-shaped wings angle back sharply, and the tail stabilizer stands upright like a modern fighter jet's rudder. But is this really evidence of prehistoric aviation, or does it reveal something even more fascinating about how human imagination interprets the past? Mainstream archaeologists offer a more grounded explanation. The carving likely represents a mythological creature or sacred symbol, embellished with artistic flair. The Assyrians frequently depicted hybrid beings, winged bulls, lion-headed eagles as guardians of their temples. This particular relief was found alongside other celestial imagery, suggesting it might portray a sacred tree, stylized with solar rays, or a deity's chariot transformed into abstract shapes. The so-called tailfin could be a flowing ribbon or ceremonial standard, while the propeller might depict a pine cone, a common fertility symbol in Mesopotamian art. Critics of the aircraft theory point out that the relief lacks key mechanical details: no landing gear, no visible cockpit windows, nothing that definitively suggests engineering rather than iconography. Yet the debate takes an intriguing turn when we examine the object's proportions. Aerodynamic engineers who have analyzed the carving note that the wing-to-body ratio mirrors that of a stable glider, and the slight dihedral angle of the wings would provide natural lift, features unlikely to emerge by pure artistic accident. In the 1970s, aviation enthusiasts built a scaled-up radio-controlled model based on the relief's dimensions, and to their surprise, it flew effortlessly, requiring no modifications to achieve stable flight. This doesn't prove ancient Assyrians had aircraft, but it does raise questions about whether they observed natural aerodynamic principles in birds or wind-borne seeds and ritualized them in art. The most compelling counterpoint comes from comparable artifacts. Similar winged discs appear across ancient cultures, from Egypt's Horus Sun discs to Mesoamerican serpent motifs, yet none were ever functional flying machines. These symbols likely shared a common archetype: the human fascination with the sky's mysteries. The Assyrians, renowned for their astronomical observations, might have encoded celestial knowledge into symbolic art, blending observation with mythology. Alternatively, some scholars propose the carving depicts a meteor or comet, its fiery tail misinterpreted as wings by modern eyes. What makes this relief truly remarkable isn't its potential as a literal aircraft blueprint, but what it reveals about cultural memory. Even if it's purely symbolic, the fact that its form aligns so closely with modern engineering hints at a universal intuition about flight, one that ancient artists captured instinctively. The Baghdad aircraft relief doesn't need to be a crashed UFO to be revolutionary. It stands as a testament to humanity's timeless urge to reach beyond the Earth, whether through mythology, art, or the silent language of shapes that somehow foreshadowed the future. In that weathered stone, we see not just a puzzle, but a mirror reflecting our own relentless drive to conquer the skies. Buried in the dusty corners of a private Peruvian museum, the Ica stones present one of archaeology's most polarizing puzzles: thousands of volcanic rocks etched with images that shouldn't exist. Hippos grazing in South America, humans riding pterodactyls, and surgeons performing cesarean sections with gleaming tools. These aren't the crude doodles of prehistoric artists, but detailed engravings that clash violently with established history. Discovered in the 1960s near the town of Ica, these stones ignited a firestorm. Were they smoking gun evidence of lost civilizations coexisting with dinosaurs, or an elaborate hoax crafted to exploit our fascination with the forbidden? The debate hinges on two irreconcilable narratives. Proponents of the stone's authenticity highlight details that defy simple forgery. Microscopic analysis reveals oxidation in the engraving's grooves, suggesting they predate modern tools. Some depict star constellations with precise astronomical alignments matching ancient celestial maps, while others show complex medical procedures, organ transplants, blood transfusions rendered with anatomical accuracy that would have been impossible for a 20th century farmer to fabricate without formal training. The most controversial stones feature humans interacting with creatures indistinguishable from stegosaurs and triceratops, their scales and crests rendered with zoological precision. Paleontologists confirm these dinosaurs weren't fully understood until decades after the stone's alleged discovery, raising the eerie question: how could a forger replicate details science hadn't yet uncovered? Skeptics, however, wield equally compelling evidence. The stones first gained attention through a local farmer named Basilio Ashuya, who later admitted to carving many himself using dental tools and aging them with cow dung. Experts note stylistic inconsistencies. The ancient scenes include anachronisms like European-style saddles on dinosaurs and tools resembling modern scalpels. Radiocarbon dating of organic residue in the engravings traces some stones to the mid-20th century, aligning with Ushuaia's timeline. Even the astronomical alignments crumble under scrutiny. While a handful match ancient star charts, others conflate constellations from different eras or hemispheres, like a clumsy collage of celestial snapshots. Yet the plot thickens when examining stones not tied to Ushuaia. Indigenous Quechua elders have oral traditions of similar engraved rocks hidden in sacred caves, described as records left by the Hatun runners, a mythic race of giants. Spanish colonial records mention priests confiscating blasphemous stones depicting unnatural creatures in the 1600s. Even more intriguing are geological reports of identical stones embedded in ancient riverbeds, their surfaces weathered in ways consistent with centuries of natural erosion. Could some be authentic artifacts later drowned out by forgeries, like whispers lost in a shouting match? Modern technology has only deepened the divide. Scans of the museum's collection reveal variations in mineral deposition within the engravings, suggesting multiple carving periods. Some exhibit patina layers consistent with centuries of oxidation, while others show tool marks unmistakably modern. This duality hints at a tantalizing possibility that a core of genuine ancient artifacts was rediscovered and then flooded with replicas to meet tourist demand. The Ica stones might not be all hoax or all history, but a murky blend of both, where truth and deceit intertwine like the vines of the Amazon. What lingers isn't just the question of authenticity, but why these images resonate so powerfully. Whether ancient prophecy or modern con, the stones tap into a primal curiosity about humanity's lost chapters. In their grooves, we see our own hunger for a past wilder than textbooks allow, a world where the impossible might yet be true. And that, perhaps, is their most enduring magic, not proof of dinosaurs among us, but proof of our endless desire to believe in mysteries larger than time itself. In the silent sands of China's Tarim Basin, a burial site older than the Great Wall holds a secret that rewrites the history books. Rows of perfectly preserved mummies with striking European features, clothed in vibrant plaid textiles that predate Celtic tartan by over 1,000 years. These aren't the expected ancestors of modern East Asian peoples, but tall, fair-haired individuals with high cheekbones and round eyes, their bodies adorned with intricate tattoos of spirals and animals that mirror designs found in ancient Ukraine. Discovered in the 1990s by archaeologists surveying the Taklamakan Desert, these mummies present a riddle wrapped in wool and time. How did people with such distinctly Western traits become buried in the heart of Asia over 3,800 years ago? The textiles alone are a revelation. Woven from fine wool and dyed deep reds and blues, some feature complex herringbone and checkerboard patterns identical to fabrics found in Bronze Age Austria. One particularly well-preserved cloak could pass for Scottish tartan, yet carbon dating places it between 2000 and 1000 BC, centuries before Celtic culture emerged. The weave's tightness suggests advanced loom technology, while residual plant dyes indicate trade networks spanning thousands of miles. These weren't crude nomadic garments, they were the haute couture of their day, tailored with precision that implies generations of textile expertise. But it's the mummies themselves that truly baffle. Genetic testing revealed they belonged to an ancient branch of the Indo-European family, possibly linked to the Afanasevo culture of Siberia or the Yamnaya steppe herders. Some bore traces of ephedra, a stimulant used in early Zoroastrian rituals in their burial shrouds, while others clutched bundles of medicinal herbs still used in traditional Chinese medicine today. Their tattoos, created by puncturing the skin and rubbing in charcoal, depict mythological scenes. A sun disk on one woman's wrist mirrors symbols found in Norse petroglyphs, while a man's sleeve of interlocking stags echoes Scythian animal-style art. The mystery deepens when examining how these outsiders thrived in such a harsh environment. Their graves contain wheels, horse gear, and remnants of cheese-making technologies previously thought to have reached China much later. Some mummies wore felted boots lined with fur, perfectly adapted to desert winters, while others had wooden eye cups to protect against sandstorms. One child's burial included a tiny leather sack filled with wheat grains, suggesting agricultural knowledge that shouldn't have existed in the region yet. These weren't lost travelers, they were long-term settlers who adapted and innovated. What's most startling is how they vanished. By the time the Silk Road flourished, their distinct culture had disappeared, absorbed or displaced by incoming populations. Yet traces linger. Modern Uyghur communities nearby still weave similar patterns into rugs, and local legends speak of red-haired devils who once ruled the desert. The Tarim mummies stand as ghostly ambassadors between worlds. Their plaid-clad bodies are testament to an era when East and West weren't separate realms, but connected threads in a vast, forgotten tapestry of human migration. In their silence, they whisper a truth far stranger than fiction, that history's borders were never as fixed as we imagined. From the celestial predicting gears of the Antikythera Mechanism to earthquake-proof walls that still stand after millennia, these hidden innovations shatter the myth that ancient civilizations were primitive. Imagine a world where Roman concrete healed its own cracks, where Inca surgeons performed successful brain surgeries, and where Viking navigators crossed oceans guided by crystals bending sunlight long before modern science could explain how. These weren't flukes, they were calculated breakthroughs, proof that ingenuity isn't tied to eras but to human curiosity. Think about the Baghdad Battery, a 2,000-year-old artifact capable of generating electricity. Or the Nazca lines etched into desert plains with such precision they can only be fully seen from the sky. No drones, no satellites, just meticulous calculation and patience. And who could forget the Delhi iron pillar, rust-resistant for 16 centuries thanks to a phosphorus-rich alloy that modern metallurgists only decoded in the 1970s. These weren't just ahead of their time, they existed outside of it, challenging the linear narrative of progress we cling to. Yet the most haunting question isn't what they achieved, but how much was lost. When libraries burned and empires fell, how many blueprints vanished into the shadows? The Antikythera Mechanism's gears hint at a wider tradition of Greek mechanical engineering, while the Mayan calendar's accuracy suggests generations of unrecorded astronomical observations. Were these innovations the peak of their fields, or just fragments of even greater knowledge that didn't survive the wreckage of time? So, what stunned you the most? The medical mastery of trepanation, the eerie precision of the gate of the sun's celestial alignments, or something else entirely? Drop your thoughts below, because history isn't just a record of the past. It's a mirror reflecting how much we still have to learn from those who came before us. After all, if they could achieve so much with so little, imagine what secrets might still be waiting, buried in ruins or hidden in plain sight, whispering to us